Hello friends, I welcome you in lecture number 8 on beta and gamma functions. In this lecture we will do some more problems on beta and gamma function. So let's start with example number 1. Evaluate integral 1 plus x raised to m times 1 minus x raised to n from minus 1 to 1. Here m and n are natural numbers. So we have to convert this integral in terms of either beta or gamma function. So for that we have to change the original variable, which is x. So we have to consider proper substitution. Here we are having 1 plus x and 1 minus x in the given function. So if we consider x equal to cos 2 theta, then 1 plus x will become 1 plus cos 2 theta and 1 minus x will become 1 minus cos 2 theta. And as we know, 1 minus cos 2 theta is nothing but 2 times sin square theta, and 1 plus cos 2 theta is nothing but 2 times cos square theta. So if we consider x equal to cos 2 theta, this function will be converted in powers of sine and cosine, and we have the formula for integral of sine and cosine if integral has limits from 0 to pi by 2. So first we try this substitution and we see whether we are obtaining limits of theta as 0 to pi by 2 or not. So we start with this substitution. We consider x equal to cos 2 theta. Then if we differentiate x with respect to theta, we will have derivative of cos 2 theta is minus sin 2 theta into derivative of 2 theta, which is 2. So therefore dx becomes minus 2 times sin 2 theta d theta. Now lower limit of x is minus 1, so we check what we obtain for theta when x equal to minus 1. So when x is minus 1, we obtain cos 2 theta equal to minus 1, and value of angle for which cosine has minus 1 is nothing but pi. We know that cosine of pi is minus 1. So here 2 theta is pi. So from this we obtain theta equal to pi by 2. And similarly we check for x equal to 1. When x is 1, cos 2 theta is 1, we substitute here. So value of cosine theta for which we obtain 1 is 0. So we obtain theta equal to 0. So when x is minus 1, theta is pi by 2. When x is 1, theta is 0. So we substitute all these things in the given integral, and we see what we obtain. New integral in terms of theta. Given integral is 1 plus x raised to m 1 minus x raised to n dx. So x is cos 2 theta and limits are from pi by 2 to 0. When x is minus 1, theta is pi by 2. When x is 1, theta is 0. And we replace x by cos 2 theta. Here also we replace x by cos 2 theta, and dx is nothing but minus 2 sin 2 theta d theta. This dx is replaced here. Dx is minus 2 sin 2 theta d theta. Now due to this negative sign, we will interchange limits from 0 to pi by 2, and this 2 is independent of theta, so we can take it outside. 1 plus cos 2 theta is replaced by 2 cos square theta, standard identity, trigonometric identity. 1 minus cos 2 theta is replaced by 2 sin square theta, and sine 2 theta we replace by 2 sine theta cos theta and integral with respect to theta. So now this is equal to, from this we will have 2 raised to m power, here we will have 2 raised to n power, and here we have 2 raised to 1 power. So we have 2 raised to m plus n plus 1, and it is independent of theta, so we can take it outside integral. Here power of cos will be 2m, here power of sine is 2n, and sine theta cos theta d theta. Again we have 1 power of 2 here, so that is going to be m plus n plus 1 and plus 1, that is 2, and this again we rewrite by combining powers of sine and cosine. So here we obtain sine raised to 2n plus 1 theta, and power of cosine is 2m plus 1. So now we are able to use that standard formula. If integral contains powers of sine and cosine, and if limits of integral are 0 to pi by 2, then as we know, here we have to consider power of sine plus 1 divided by 2, gamma function of that quantity. Here gamma function of power of cosine plus 1 divided by 2. In the division we have 2 times power of sine, that is 2n plus 1, plus power of cosine, that is 2m plus 1 plus 2 divided by 2. So here we are using that formula which we have derived in earlier lectures. Integral from 0 to pi by 2 sine raised to p theta cos raised to q theta d theta. This is given by gamma p plus 1 by 2, here gamma q plus 1 by 2 divided by gamma p plus q plus 2 divided by 2, and this formula is valid for p greater than minus 1 and q greater than minus 1. So now we simplify this and we see what we obtain. So here we have 2 in the division, so that will cancel out 1 power of 2. So it is 2 raised to m plus n plus 2 minus 1. So that is going to be 2 raised to m plus n plus 2 minus 1, that is 1. This we can rewrite as 2n plus 2, that is 2 into n plus 1 divided by 2. So we write one more step, 2n plus 2 divided by 2. Here we will have 2m plus 2 divided by 2. 2m plus 1 plus 1, that is 2m plus 2 divided by 2. Here 2n plus 2 divided by 2, and in the denominator we have 2n plus 2m and plus 1 plus 1 plus 2, that is 4. So it is 2n plus 2m plus 4. (2n plus 2m plus 4 divided by 2). So we again simplify this. This is 2 raised to m plus n plus 1. Here 2 will cancel out and we will have gamma n plus 1. This is gamma m plus 1. Here also 2 will cancel out. Same thing here. And here also we can cancel out 2. So we are left with gamma n plus m plus 2. Now in the given problem we are given that this m and n are natural numbers, so therefore we can use that recurrence formula. Instead of gamma n plus 1, we can write n factorial. This we can write as m factorial, and this we can represent as n plus m plus 1 plus 1, and we are using that recurrence formula, gamma n plus 1 equal to n factorial if n is natural number. So now denominator is nothing but factorial of n plus m plus 1, because n and m are integers, so n plus m plus 1 is also integer. This is n factorial, this is m factorial, and here we have n plus m plus 1 factorial. Again using this recurrence formula, instead of n we have n plus m plus 1, so it is n plus m plus 1 factorial. So this is the answer of given integral. Therefore we obtain minus 1 raised to 1, 1 plus x raised to m, 1 minus x raised to n dx. This is equal to 2 raised to m plus n plus 1 times n factorial into m factorial divided by n plus m plus 1 factorial. So what is new thing in this problem? Here we are having different substitution, 1 plus x, we are having 1 plus x into 1 minus x in the integral of given function. So we are considering this substitution, x equal to cos 2 theta, so that we are able to convert this integral in powers of sine and cosine. So now we consider this example number 2. Here our integral is integral from 3 to 7, fourth root of x minus 3 times 7 minus x. So first we denote given integral by integral from 3 to 7, fourth root of x minus 3 times 7 minus x. So first question is which proper substitution we have to consider. So before that we can rewrite this integral as x minus 3 raised to 1 by 4 times 7 minus x raised to 1 by 4. So suppose we are trying to convert this integral in terms of beta function, then definition of beta function is integral from 0 to 1 x raised to m minus 1, 1 minus x raised to n minus 1 dx. This is given as, this is the definition of beta function. So instead of x we have x minus 3, instead of 1 minus x we have 7 minus x. So suppose we are considering this substitution, we replace x minus 3 by some another variable, say y. Then we check whether we are obtaining limits as 0 to 1 or not. So when x is 3, y will be 0. If I put x equal to 3, I will obtain y equal to 0. But when x is 4, when x is 7, we will have y equal to 4. But we require upper limit of new variable as 1. So we have to consider some change in this substitution. So suppose we consider x minus 3 equal to 4 times y. Then when x is 3, 4y is 0, that is y is 0. And when x is 7, we have 7 minus 3 equal to 4y, that is 4 equal to 4y, and we will obtain y equal to 1. So we will try this substitution, x minus 3 equal to 4y, to convert given integral in terms of beta function. So we consider this change of independent variable from x to y as x minus 3 equal to 4y. Then x is nothing but 3 plus 4y, and therefore derivative of x with respect to y is nothing but 0 plus 4, that is 4. So therefore dx is 4 times dy, and we write down limits also. X equal to 3 implies y equal to 0. It implies 4y equal to 0, that is y equal to 0, and x equal to upper limit, which is 7, implies 4y equal to 7 minus 3, that is 4, and this implies y equal to 1. And we simplify this 7 minus x also, and 7 minus x is nothing but 7 minus x is 3 plus 4y. So you can see we obtained 7 minus 3, that is 4 minus 4y. So using all these things, our integral becomes I equal to integral from 0 to 1. X minus 3 is 4y, so we have 4y raised to 1 by 4 power. 7 minus x is 4 minus 4y, so 4 minus 4y raised to 1 by 4 power, and dx is 4 times dy. Okay, fine. So now we can rewrite this as integral from 0 to 1. This is 4 raised to 1 by 4 times y raised to 1 by 4. Here also we will have 4 times 1 minus y, that is 4 raised to 1 by 4 times 1 minus y raised to 1 by 4 into 4 dy. And here we have written this as 4 times 1 minus y, and power of 4 is 1 by 4 as well as power of 1 minus y is 1 by 4. Now we consider all the quantities which are independent of y outside the integral. So that is 4 raised to 1 by 4 plus 1 by 4 power of 4 and plus 1. Base is common 4, so we are adding the powers 1 by 4, 1 by 4, and here 1, and inside the integral we have y raised to 1 by 4 times 1 minus y raised to 1 by 4 dy. Now if we simplify this, this is going to be 1 by 4 plus 1 by 4, that is 2 by 4, which is 1 by 2 plus 1. And now we compare these powers of y and 1 minus y with m minus 1 and n minus 1. So we obtain m minus 1 equal to 1 by 4, and that gives me m equal to 1 plus 1 by 4. And similarly n minus 1 is 1 by 4, so that gives me n equal to 1 plus 1 by 4. So if we use the definition of beta function, this is nothing but beta function of 1 plus 1 by 4, that is 5 by 4, and here we obtain same thing. So it is nothing but beta function of 5 by 4 comma 5 by 4. We are using the definition of beta function. Beta mn is nothing but 0 to 1 y raised to m minus 1 1 minus y raised to n minus 1 dy. So here m is 5 by 4, n is 5 by 4. So value of this integral is nothing but beta function of 5 by 4 comma 5 by 4. So now this is nothing but 4 raised to 3 by 2, and now using the relationship between beta and gamma function, we have gamma m gamma n divided by gamma m plus n, that is 5 by 4 plus 5 by 4. Using the relationship between beta and gamma function, we know that beta mn is given by gamma n divided by gamma m plus n. Here m and n both are 5 by 4. So now this 4 raised to 3 by 2 can be written as 2 square raised to 3 by 2, and we rewrite gamma 5 by 4 square here. It is 2 times gamma 5 by 4, and here we will have 2 times 5 by 4, that is going to be gamma 5 by 2, and this is 2 raised to 3. Here we will have gamma 5 by 2, and here we write 5 by 4 as 1 by 4 plus 1. Now using the recurrence formula, gamma 1 by 4 plus 1 is nothing but 1 by 4 gamma 1 by 4 whole square, and here also we rewrite gamma 5 by 2 as gamma 3 by 2 plus 1. So this is going to be square of 1 by 4, that is 16. This is gamma 1 by 4, and here we have 3 by 2 times gamma 3 by 2, and here it is square of gamma 1 by 4, and this 8 will cancel out with this 1 by 16. There will be 2 here, and that 2 will cancel out okay, let me write one more step. 8 into 1 by 16, that is gamma 1, that is 1 by 2. Here square of gamma 1 by 4, here 3 by 2, and gamma 3 by 2 is nothing but gamma 1 by 2 plus 1, that is 1 by 2 gamma 1 by 2. So this 1 by 2 will cancel out, and gamma 1 by 2 is square root of pi. So we have gamma 1 by 4 square, and here if we take 3 by 2 in the 1 over 3 by 2 is 2 by 3. So we will have 2 divided by 3, and gamma 1 by 2 is square root of pi. Now we don't know what is gamma 1 by 4, because 1 by 4 is less than 1, so we have no formula for evaluating this gamma 1 by 4. So we can try by definition, but if we go by definition, we will have gamma 1 by 4 equal to 0 to infinity e raised to minus x raised to n minus 1, that is 1 by 4 minus 1 dx. So here also we have problem in evaluating this integral, because this is going to be x raised to 1 minus 4, that is minus 3 by 4 dx. So integral is not easy. So it is fine, we keep gamma 1 by 4 as it is. Our answer is in terms of gamma function. So in this problem, what is new thing here? The new thing is substitution. First we tried x minus 3 equal to y, but it has not worked. So we have taken x minus 3 equal to 4y, so that we are able to convert our integral in terms of beta function. And then we are using the relationship between beta and gamma function, and also we are using definition of beta function here to convert this integral in terms of beta function. So this is all about today's lecture. I hope you like this lecture. Thank you very much.